Hey folks, welcome back. In this lecture, we are going to talk about relational and logical operators. So relational operators allow you to compare two things and see whether one is bigger, one is smaller, if they're equal, if they're not equal, and some other stuff related to that. So we've talked about the Boolean data type, and we said that a Boolean can hold either true or false. And it was really hard to come up with an example of when you would actually use a Boolean data type. So in most of that lecture where we talked about it, we just kind of breezed over Boolean and said, yeah, it's a thing. So today we're going to look at why you might actually use a Boolean type. And it turns out that with relational operators, they're always going to evaluate to a Boolean. And this is true in the real world as well. If I asked you whether the lights are on in the room here, you would say, yes, they are. And effectively what you're doing is you're saying true, they are on. And the reason that you know that is because you looked at the light and you can see that it's lit. And so you're doing a comparison. In this case, it's not really relational. You're just kind of relating to how much light there is in the room and making a prediction about whether the light is on. But in the end, it came back as true or false, which is a Boolean. So in the real world, we use Boolean all the time. We just don't really think about it. Is it raining today? That's a Boolean. Is it really hot today? That's a Boolean. Is it really cold today? That's a Boolean. Did you get up and go to class today? That's a Boolean. Are you passing your classes? That's a Boolean. So you use Boolean all the time. You just don't really think about it. And it comes up very often when you're doing any kind of relational operators, where you're comparing if one thing is bigger than or smaller than something else. So let's take a look at the code that we have here on the screen. So the first thing to notice is that we have basically Boolean higher equals 7 greater than 3. And so we're creating a variable of type Boolean. We're calling it higher. And then we have a statement which is 7 greater than 3. Well, 7 is greater than 3, so that's going to evaluate to true, and therefore the value of higher is going to be true. And you can actually print out a Boolean, which is not something we really talked about before because it's a little weird, but it certainly works. So let's take a look at some examples here. So we have Boolean is true equals, there we go. And you can do anything. So like, let's say 18 less than 22. And then I'm going to print out is true is plus is true. Okay, this may not be the greatest variable name in history, but this will certainly work. So is 18 less than 22? And the answer is, I put in an extra set of parentheses. The answer, of course, is yes, 18 is less than 22, so it's going to print out is true, is true. Is true, is true. Is true, is true. Okay, may have picked bad variable names. So what we have here is a Boolean expression, and we can certainly have more than one Boolean. So we can have Boolean, let's call it raining, equals, and then we're going to say 99 less than 105. Well, let's do something that's not true. Let's do 99 less than 99. Okay. And so raining is never getting printed out, so we're never going to see any output. So let's go ahead and fix that. All right. Not sure raining is a better variable name, but at least it is true. Is true. All right, so raining in this case comes out to be false, and that's because 99 is not less than 99. So relational operators have to be very precise. If you say that something is less than something, it has to actually be less than. It can't be less than or equal to. If you meant less than or equal to, you have to specify less than or equal to. All right, so you will sometimes hear these referred to as relational operators. You'll hear them referred to as comparison operators. You'll sometimes even hear them referred to as Boolean operators. And I want you to realize that all those things mean the same thing. They're basically just comparing two values and seeing whether they are greater than, less than, equal to, or not equal to, or whatever the comparison is that you're doing. And so here we have 7 is greater than 3. 7 is greater than 3, and that is true. And 14 is less than 7 is also false because, well, it's not less than 7. So what operators do we have? We have greater than, we have less than, we have greater than or equal to, we have less than or equal to, we have equal to, and we have not equal. And all of those, less than, greater than, equal to, no space here, that's very important. Likewise, no space in between those two, that's very important. All the first four, they all seem to make good sense. And then you get to this one. This is probably the most common mistake that everybody makes in programming for the first year of their lives, of their programming lives, which is to test if two things are equal, you don't say equals, you say equals equals, because reasons. All right, and then as far as checking to see if things are not equal, it's an exclamation equal. And that kind of makes sense, as you'll see why in a moment. So as I mentioned, this is a very important detail. Equals is for assignments. We've seen this before. Int x equals 7. That is assigning the value 7 to x. It's not comparing x to 7 or anything else. It's just setting x equal to 7. Equals equals is for testing if two things are equal. So 7 equal 8 is false because 7 is not equal to 8. If you were to do the wrong one, the computer will accept it because they both have meaning. It just will do the wrong thing. All right, so equals is not equal to equals equals. We're very clever over here. All right, so this last statement here is a bit confusing, and I don't want you to focus too much on it, but I do want you to realize that this is a valid statement. X equals 7 equals 8. So assuming that x is a boolean, which it is, then what we're doing is we're assigning to the boolean x, that's what this first equals is doing, the value of 7 equal 8, which is false. So at the end of all of this, x is equal to false. All right? And I, again, don't focus too much on this, but I do want you to realize that equals is how you compare things. Equals is how you assign one thing to another. It is by far the most common mistake people make. Often people will write, if x equals 7, do something, and that's not going to work because it's a assignment, and you can always assign 7 to x, whether its value was 7 or not before. All right, so before we jump into the string stuff, let's take a look at doing some Boolean operators here. So I'm going to say Boolean, what am I going to do? Sorry, I'm going to do int x is equal to 7, int y is equal to 15, and z is equal to 7. Now I'm going to say Boolean is true, here we go again, is equal to x equal z. All right, and then I'm going to print out is true colon plus is true. All right. So when this runs, it's checking to see if x is equal to z. X is 7, z is 7. And I already have an is true. Well, not only is it a bad variable name, I have already used it. My test. There we go. That's better. My test. All right. So the problem there was that it found that there's an is true up here, and then I was trying to define is true down here, and I can't do that. All right. So my test is going to be assigned x equals z, and x is equal to z because x is 7 and z is 7, so therefore that is true, and therefore it is true, or my test is equal to true. All right. Okay, so we've seen less than, greater than, less than or equal to, greater than or equal to, equal, and we have seen exclamation equal. But in each of these cases, we are comparing numbers or we're comparing letters. In this next example, we're going to be comparing strings. Unfortunately, in Java, strings are handled differently. You can't just use an equal, you have to use a dot equals, and that's a little bit confusing. So what we're going to do here is we're going to read in a line of text from the user using our read statement with a scanner. We're going to say string A is equal to my scan next line, and then string B is equal to my scan next line. So that's going to read in two separate lines from the user, store one of them in A, and store the other one in B. And then I'm going to check to see if the two of those are the same. And normally you would think that you would do something like this, but that's not going to work. So what you instead need to do is you're going to need to say boolean are the same is equal to a dot equals b. All right, so let's do this in Replit real quick. So I'm just going to delete all of this, and we're going to ask the user to enter in a line of text. So we'll ask them, tell me your name. All right, and we need a scanner object here, so I'm going to import java.util.Scanner, and then I'm going to create a scanner object. So scanner myscan equals new scanner system.in. All right, now I'm going to read in the first line of text. Scanner is going to read in a string, so I'm going to create string name1 is equal to myscan.nextLine. All right, now I'm going to ask the user to enter in another name. So tell me another name. And this time I'm going to read that into a variable called name2. So I have name1, which was the first name that they read in, and name2, which is the second one. So just to get started here, we're going to print out both of those names. So name1 is plus name1, and name2 is, and then plus name2. All right, and I'm just going to move this window over a little bit so I can see what I'm doing. And we're missing a semicolon there. All right, so far we're not doing anything with booleans. We're just reading in the two names. As I've said before, you should always write small amounts of code and try to test them first and make sure that they work before you write all of it. So tell me your name. My name is Enda. Tell me another name, Jerry. And it says name 1 is Enda, name 2 is Jerry. So that seems to be working good. Now what I want to know is, are the two names the same? So again, what you would typically have done, so you create a boolean, we'll call it same name. And what you might have thought to do is say same name equals name1 equal name 2. And that is wrong. So I'm going to put that here and say this is not how you do it, even though that's probably what you would want to have done. So instead, the way that we're going to do it is we're going to say same name is equal to name1 dot equals parentheses name2. And that's weird, but that is how you compare two strings in Java. All right, so now I'm going to print out they are the same, and then the value of same name. All right, so let's run this. And we're going to try it a couple of times. So the first time I'm going to type in Enda and Jerry the same as I did last time, and those are obviously not the same. So when I give it Enda and Jerry, it says they are the same, false. That's what we would expect because they are not the same. Now I'm going to run it again, and this time I'm going to type Enda and Enda. And you can see this time it says they are the same, true. So that's how you compare a string. Now, I know this is confusing. You have greater than, less than, greater than or equal to, less than or equal to, and then you have equals, equals, and you have exclamation equals. And all of those work for numbers. You need to remember that those are numbers pretty much exclusively. You can use them on characters. You can say is C less than D, and it does understand that, but for the most part, they're numbers. If you're doing any other kind of comparison with strings or with some other things that you'll learn later, there's going to be a different way that you're going to have to do that. With strings, it's using this dot equals method, which compares two strings and tells you whether they are the same. There's a big technical reason as to why equal equal doesn't work the way that you want it to work. You will find that sometimes it will give you the right answer, but it is not a reliable way to compare strings. And it's beyond the scope of this class to explain that, but you'll learn more about that when you get into 1321 and 1322. All right, so because strings are special, it also has a few other things that are useful. And for example, you might want to be able to tell whether the strings are the same even if their cases are different. And so that's where we get equal ignore case. So this works the same as dot equals, but if you typed Enda with a capital E and Enda with a lowercase e, dot equals would be false because those are two different strings. But dot equals ignore case would be true because ignoring the case, uppercase, lowercase, they are the same. So dot equals and dot equals ignore case are two useful ones. There's also something called dot compare to in Java, which will return a number. If the two strings are the same, it will give you the number 0. if one string is less than the other string, and that's by comparing them, so like looking at the first letter of the word and then seeing which one alphabetically is before the other one, it will give you a negative number. And if they are if the second string is later than the first one, it'll give you a positive number. So that's also sometimes useful if you're trying to rank or order strings. All right, so that is comparing strings. And next up, if the computer will behave itself. Okay, let's try clearing the screen. Maybe that was the problem. There we go. Okay, so next up we have an example here where we have string A is equal to high with a capital H, and then string B is equal to high with a lowercase h. And what's going on here is we're defining two strings. One of them is called A, one of them is called B, and they have similar but not the same string. So now we're going to use that compare to method. And so we're going to say A, which is the first variable, compare to B, which is the second variable, and that's going to return back an integer number, which is the comparison of the two. In this particular case, it's going to return negative 32 because it turns out that an lowercase h is 32 positions before an uppercase h when you lay out all the numbers in an ASCII chart. All right, and then if we do equals ignore case, that's going to return true because those two are indeed the same if you ignore the case. All right. So this brings us to the last topic of today, which is logical operators. Logical operators are used when you need to compare more than one thing. So you've seen these before when we dealt with logic gates. It's actually how computers are built. They're built with logic gates that are allowing it to do comparison of ands and ors and nots and some other combinations of those that can be used to do basic math and everything else. Those same logic gates exist in Java, except they are operators that we call logical operators. So you have an AND operator, an OR operator, and a NOT operator. And so let's take, for example, if you were asking the user to enter in a number between 0 and 100, you might want to check that they gave you a good number. So in that case, you'd want to check that the number is greater than 0 and that the number is less than 100, because there are two separate things that you want to do. All right, so the AND operator in Java is used as this strange character down here, which is two ampersands next to each other. There cannot be a space in between the ampersands, so it has to be ampersand, ampersand. The OR operator in Java, this is really being weird. Okay. Okay, so let's take an example of an AND operator. And so our first example here, what we're doing is, again, we're importing scanner and we're creating a scanner object, and then we're asking the user to enter in a number between 0 and 100. All right, and then when we read in that number, which is happening on this read line right here, we're storing that in an integer called user number. And so now we're going to check and see, did they do the right thing? So I'm creating a boolean called success, and it's going to compare two things. So the first thing is it checks to see is user number less than or equal to 100, and the second thing it's checking is user number greater than or equal to 0. So let's presume that the user typed in 17. So the first one is going to check 17 less than or equal to 100, and obviously that's going to be true. And then it's going to check 17 greater than or equal to 0, and that's going to be true. And then the way that an AND operator works, true and true is going to be true. So an AND operator only returns true if both sides were true to start with. So that's how this would get evaluated. It does the relational comparisons first, meaning user number less than or equal to 100, user number greater than or equal to 0. Those are each independently evaluated. And then the AND operator is done last to compare the two of those and see which one is higher. All right, so that brings us to the OR operator. The OR operator in Java is done with something called a pipe. So the symbol is that, which I just circled. It's two lines, and typically you get to that on your keyboard. It's usually on the key above your enter key, and it'll be a straight line, or it's perhaps two straight lines, one above each other. It's not a colon where you've got two dots above each other, it's two lines or a single line. On my keyboard, it's a single line. On yours, it may be two. So usually it's the shift of the key above the enter key, and you type two of them to do an OR. All right, so let's take an example of an OR. All right, so we have something similar going on here. We're reading in a scanner, and we have enter a choice, A or B, and then we're going to read in a single letter from the user. Now, you remember when you're reading in a single letter, you have to do this weird thing, which is myscan.next parentheses .char at 0. That will read in one character, and we're storing that in user input. All right, and then we're saying success if the user input is equal to a capital A or the user input is equal to a capital B. So again, it's going to evaluate whatever value is in user input. It's going to see if that's equal to a capital A. Then it's going to do the other comparison. So it's going to check whatever the user input is and compare it to a capital B. And these are just characters. They're not strings. So we are using equal, not dot equals. So in each of these, they're going to return either true or false. Well, just for a moment, we'll assume that they gave us a capital A. Then the first one would evaluate to true, and the second one would evaluate to false, because capital A is not equal to capital B. So that would give us true or false. And the way that an OR operator works is that if either side is true, the answer is true. So that's going to evaluate to true for us, and then that's going to print out true. All right, and so that is the OR operator. And that brings us to the last one of the three, which is the NOT operator. And in Java, the NOT operator is going to be a single exclamation mark. That one's easy to find on the keyboard. And so here's our example of that. We have, again, a scanner, and we are reading in, asking the user to enter in either true or false. And then we read in next boolean. That's how we read in a boolean. And we store that in user bool. All right, so opposite is a new variable, and it's going to be equal to not user bool. So whatever the value of user bool was, not is going to reverse it. When you think of not, this one is actually useful to think about with a light switch. If the lights are currently on and I tell you to switch the switch, the only possible choice is that you'll turn the lights off. And if the lights are currently off and I tell you to switch the switch, they'll be turned on. The not operator does that. It's going to reverse whatever the current value of the boolean is. So if the boolean is true, not makes it false. If the boolean is false, not makes it true. So if the lights are on, not would make them off. If the lights are off, not would make them on. It does get a bit confusing to say out loud, because if I say the lights are not on, then you know that the lights are off. And if the lights are not off, then you know that they're on. So it's a little weird to say it, but there it is. All right, so let's take a more complex example of all of these. All right, so we start off and we are going to declare a bunch of variables. So we have a float, a char, an int, and a couple of strings that have values in them. So the float is 13.3f, and that f is there because I need to force it into a floating point number. The char is capital X. The int is going to be set to 27, and then the first string is going to be the word test with a capital T, and the second string is the word test with a lowercase t. So now we're going to do our big, long evaluation down here. So when you look at this, it might be a little bit overwhelming at first, but you're going to do it bit by bit. The first thing that's going to happen is any of the arithmetic operators. So we're going to begin by taking a plus c, and we're going to evaluate that first. All right, so the value of a is 13.3, and the value of c is 27. So if you add those together, that's going to give you 40.3. Let's try that again. All right, so that's going to be 40.3. All right, there's no more math anywhere in this equation. So now we're going to do the next step, which is going to be the relational operators. So we're going to compare 40.3 to 55, and we're checking, is 40.3 less than 55? And the answer to that is true. 40.3 is indeed less than 55. All right, so all of this is now true. The next thing we're going to check is the next relational operator, which is going to be b equal to capital Y. So if we look at the value of b right now, it's a capital X, and a capital X does not equal a capital Y. So this part is going to evaluate to false. All right, so that gave me true and false, or D equals ignore case E. All right, so let's do this next one over here, again, because it's relational. So D equals ignore case E. The current value of D is test, and we're checking if that is equal to this word, ignoring the case, and the answer to that is true. All right, so all of that got evaluated to true. So what we're left with is true and false or true. That's what's left over. And the way that that works is it's going to do the true and false first. So true and false is going to be false because with an AND operator, both sides have to be true. So that leaves me with false or true, and that is going to evaluate to true, because the way an OR operator works is if either side is true, then you get a true out of it. So in the end, the value true is assigned to answer, and when you print it out, you get this is true. So that's how you evaluate things. As a matter of fact, there's very, very specific rules as to the order in which everything is evaluated, and it's very important to remember that. This is a chart that gives you that specific order of precedent. So the very first thing that is always evaluated is anything that is inside of parentheses. So you work from the inside of the parentheses out, and if there's more than one parentheses on the line, you do them left to right. The second thing that's done are any unary operators. So if you have a -3 in there, or you have a not anywhere, these are the examples of the unary operators. Any plus pluses, any minus minuses, those are done first. Or they're done second, sorry. After that, we do all of the arithmetic operators. Specifically, we do the multiplication ones first, which is multiply, divide, and modulus. Then we do the additive ones, which are plus and minus. Then we do all the relational operators. Then we do the equals. Then we do ands. Then we do ors. And finally, we do any assignments that we might have. And again, there's multiple different ways that you can do assignments because you have plus equals, minus equals, star equals, and all those were covered in previous videos. So parentheses first, then any of the unary operators, which does include plus plus and minus minus, then arithmetic, additive, relational, logical, and then finally assignment. This is something that you definitely need to memorize, because not only is it going to be a question on a quiz or a test, but it also is a question that comes up quite often in interviews, where somebody will give you a big long statement like I just did and ask you to evaluate it and tell you what the value is. And it's just checking to make sure that you understand how things are evaluated, because if you don't, it proves that you're not able to think about more complex bits of code. So definitely memorize this chart and remember which order things are going in. All right, so we're going to do one more example here, and we're going to do this one together. And you might want to pause and make sure that you come up with the same answer. So go ahead and pause the video and then calculate what you think is going to be right, and then we'll come back and I will tell you how to do it. Okay, so we're going to start off and we're going to evaluate the parentheses. So 8 plus 6, I picked a terrible color. Let's do a red. 8 plus 6 is going to be equal to 14. All right, so this is now equal to 14. All right, I've got no more parentheses in here, so I'm done with those. Next, I have a unary operator, which is x plus plus. X was originally equal to 32, so now x is going to be equal to 33. So I'm going to cross that out and say 33. All right, so that has been taken care of. Next, we are going to look through here, and it looks like we are done with any of the unary operators, so we're going to move on to math. So we're going to do multiplications first, left to right. So the first one of those is going to be this one, which is 14 times 3, and that's going to be 42, 3 4s are 12, and 30, yeah, that's going to be 42. All right, next up we have mod 2, and that's the same level of precedent as the multiply, so we're going to do it next because it's left to right. 42 mod 2 is going to be 0, because 2 goes into 42, it doesn't matter, and there's nothing left over. 2 is going to go in evenly into 42. All right, so that left us with all of this being evaluated to 0. Next here we have 6 divided by 3, and that's going to be equal to 2. And then we have this plus x, and that is going to give us plus 33, which is going to give us 35 here. All right, so now 0, we're done with all of the math. So now we have 0 greater than 35, and that is false. Okay, so that is everything up to that line that I just drew. That all evaluated to false. So now we're left with false and not true. Oh, I missed this one at the beginning. This should have been done with the unary operators, sorry. But that's easy to deal with. So not false is true. True false was equal to false at the beginning. And so that not is going to reverse it, which makes it equal to true. And then that leaves me with false and true, and that's going to be equal to false. So that's how you evaluate all of that. And if we take a look on the next slide, I have given you the details of how you do that. So we have the parentheses first, and then we have the unary operators, which is that. And then we had the not true. That should have happened in that one as well, because that's a unary operator. And then next up, we had multiply, which is this bit. And then we had a mod, which is this bit. And then we had a divide, which is that bit. Those are all the same level. And then next up, we had a plus, which is this bit. And then we had our relational operators, which was this bit. Oh, I underlined too much for the plus there. Sorry. The plus was really only just that bit. Sorry. The unary operator, or sorry, the relational operator is now going to be this guy. And then finally, we do the logical operators, which are the ands at the end. And that does give us false in all of there. All right. So that is the logical operators and also the relational operators and the logical operators. Sorry. All right, so the final topic for today is we're going to talk about having the computer pick a random number for you. And this comes up occasionally. So if we need the computer to pick a number, we might need it to pick a number between 0 and 10. And you might say, well, why would you ever want to do this? Well, anytime that you're doing anything where you're playing a game or something like that, you probably want the computer to change the game every time that you play it. So let's imagine you wanted the computer to pick a number between 1 and 10, and then you wanted to guess it. It would be boring if you had to code in there that the answer is 6 always. So it would be nice if the computer could randomly pick a number for you. And so that's what we deal with random. So much like Scanner, there's a couple of lines that you're just going to pretty much have to memorize for this. Anytime that you need a random number, you're going to need to import java.util.Random. And then you're going to make a random object, and then you're going to tell it to pick a number. So let's look at those steps in an example. So here we have an import statement, import java.util.Random. And then we have, similar to the Scanner line, and again, you're just going to memorize this for now, random myrand equals new random. That creates for you a variable called myrand, which is of type random. And then in order for the computer to pick a random number, you say myrand.nextint, and then you tell it how big of a number you want it to pick. So in this case, I'm asking it to pick a number between 0 and 10. Specifically, it will pick 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. It will never pick 10. So the 0 is inclusive, but the 10 is exclusive. It won't pick the 10. So that will give us a number that is between 0 and 10. So if you wanted it to pick a number between 0 and 1,000, you would simply have changed that last line to nextint parentheses 1,000. So whatever you put in the parentheses is how big of a number it will pick. And again, this one will pick between 0 and effectively 999. If you need something that is a bigger range, so like you're picking something that's not between 0 and something, then you can also use addition to get you to where you need to be. So for example, if you need to pick a number between 1,000 and 1,200, which is what's going on here, then what you would first do is pick a number between 0 and 200, and you would add that number to 1,000, and then that will guaranteeably give you a number between 1,000 and 1,200. And the reason that works is because if the random number was 0, when you add 1,000 to it, you get 1,000. And if the random number was 199, when you add 1,000 to it, you get 1199, which is the highest number that you can pick in there. And this happens quite often where you would need the computer to pick a random number and do something for you with that random number. I will make a comment here, which is that you need to be careful with random numbers, and the details of this are beyond the scope of this class, but suffice it to say, if you're dealing with anything that has to do with money or security, using the random number generator that I just showed you is not the way to do it, and I'll leave that for further reading outside of the scope of this class for you to figure out why, if you care. We're not going to ask you questions on that in tests, but it is the case that you should not use just the random object to create numbers that you're using for money or for security. And you might say, what numbers would I be using for money? Well, you could write a game like a card game, and you would pick the cards out of the deck by picking a random number between 0 and 52. And the problem with that is it's predictable if you know enough information as to what order it's going to pick the cards, which would be very bad if people are placing money bets on that or something along those lines. So anything that has to do with money, anything that has to do with security, you're not going to use that. So that's a footnote that's in there. All right, so we're going to finish off with one quick example here as soon as this loads. What I'm going to do is I'm going to have the computer pick 10 random numbers and show me those random numbers on the screen. And we're going to pick numbers between 0 and 500. So we start off with import java.util.Random, and then we're going to make a random object. So random myrand equals new random. And then I'm going to start picking the numbers. So int num1 equals myrand, and I'm going to say 500. Myrand.next. Oops. Sorry about that. Myrand dot next int 500. And that's what I meant to type. And then I'm going to go ahead and print out that number. num1. All right, and then I'm just going to do this over and over again. This time it's going to be num2. And the next time it's going to be num3, and the next time it's going to be num4. I'm just going to do this 5 times, just because it's the same thing. I'm just copying and pasting. At this point, you guys can do this yourselves if you really want to play with it. And the final one is num5. Great. Okay, so we're going to hit run on this, and what we're going to see on the screen are 5 random numbers between 0 and 500. And let's see what we get. 476, 351, 201, 357, and 100. And if I run this again, I will get completely different numbers the next time, hopefully. So that's what a random number generator looks like. You will need that probably in some of your assignments or in your tests, so definitely be sure you understand how to make a random number and how to pick one. Today in class, we've learned how to do relational operators, which are greater than, less than, greater than or equal to, less than or equal to, not equal to, and then the Java string version of that, which is dot equals, ignore case, and dot compare to. And then we've looked at logical operators such as and or, and not. And finally, we've looked at the random keyword here to generate a random number. So that's it for today's lecture, and I will see you guys next time.